Hi students, let us discuss the use of regular expressions to count the number of vowels and consonants in a string. First, we need to understand what is a lex. What is a lexical analyzer? The main job of a lexical analyzer, that is scanner, is to break up an input stream into more usable elements such as tokens. Let us consider the example of a string a equal to b plus c star d, where the following tokens are assigned. A is assigned as ID, the identifier, equal to is assign, the assignment, and so on. Lex is a utility to rapidly generate tokens. Now let us discuss about what is a regular expression. Regular expressions define tokens, since tokens are the terminals of a language. Like in English, words, punctuation marks, etc. Similar in programming language, identifiers, operators, keywords, etc. The aim of the experiment is to recognize and count the number of vowels and consonants in a string. At the end of this laboratory, students will be able to define regular expression for vowels and consonants, count and display the number of vowels and consonants. Experimental procedure. Analyze the problem statement, design an algorithm for the given problem statement, implement the algorithm in Lex file, compile and execute the Lex file, document the results, analyze and discuss the outcomes of the experiment. So the question, write a Lex program to count the number of vowels and consonants in a string. Computations and algorithms. Here the students have to write the problem-solving approach, write the algorithm for the problem statement, take screenshots of Lex program and outputs for various test cases. Problem-solving approach. Declare the necessary global variables, write the appropriate regular expression, invoke Lex functions such as yyWrap and yyLex to continuously take the input and start the lexical analysis process respectively. Algorithm. In initialization, define two global variables count C and count V, which are initialized to 0. In definition or regular expression, define the regular expression with vowels A, E, I, O, U having highest priority. The other alphabets are treated as consonants. In subroutines, that is C code, invoke yyLex, which in turn invokes yyWrap to read the input string character by character given by the user, and printf is used to display the number of vowels and consonants recognized. This is the regular expression section of the program, where it shows the regular expression for vowels and consonants by defining the expression in the following way. To compile and execute, consider the file name to be vowel with .l extension. The table shows the commands used to execute the Lex program, where lex vowel.l generates C code file named as lex.yy with .c extension and compile the generated C code file using GCC compiler, which in turn generates a executable file for respective architecture like .exe file for Windows. In results and test cases, students have to put screenshots of the outputs for various test cases. A sample of the expected output is shown in Figure 1, and the test cases for different inputs are presented in Table 1. In analysis and discussion, students have to analyze their work mostly in terms of what is the range of inputs that can be given, how the program can be improved using some other techniques or methods. In conclusion, the students have to conclude their work in terms of using regular expression, recognition of vowels and consonants. Program should be thoroughly tested for the different test cases. Thank you.
At MSR UAS, we spark your imagination unlike any other.